Hey, good morning, everyone. Good morning.
Good morning, Professor.
Hey, good morning, Samira. How are you?
I'm good. How are you?
Well, I'm fine. I'm fine. Uh, well, just glad to. I'm just glad to see four people this early. It's 11:03, and I have already four people here. All righty, and let's see. Let's just check how many people are in the forum. Okay, I have more than four actually. I have two, four, six in the discussion board. I mean, in today's forum, and so, and I have, yeah, one more person is joining. Randall's joining, so we're gonna have exactly the same number of people as in the forum. All right, so the midterm is over, and uh, some uh, some people were asking yesterday. That why they were not able to see their results. And I noticed that there was a 24-hour hold period. So you should be able to see. You should be able to see it now, okay, as of today, because I believe uh, I believe I set up that 24-hour hold period just to prevent uh, some cheating in case people who finished early, knowing their result and being able to see the correct answers, uh, might help out a close friend who hasn't finished yet. So, but that's just in case. So that was 24-hour hold period, and you should be able to see the result. And also, um, I you should have noticed that. Oh no, you couldn't have noticed this at all. But uh, if you go back, if you go to topic three folder, you will see um, that there is this file. Um, this will become available only from April 11th, which is next Monday, which is the my solution to all uh, the the midterm problems by Excel. But again, you have to understand. Actually, it's hard to. The reason it will be available only on the 11th is because some people, if it is already available, some people who are a day or two late, uh, you know, may take advantage of this. And that, of course, that's unfair for the people who have met their deadline. And besides, there is a 10% late penalty per day late. So by this time, by the 11th, you'll be 8 days late already. And if you're already 8 days late, then um, even if you get 100, that will be, after adjusting for late penalty, it will be only 20. So there is no incentive, uh, if this file is posted, uh, on 8 days later, there will be no point in anyone, trying to uh, take advantage of this and submit, late. Okay, that's one reason. And another thing is, um, no one gets exactly the same test problem sets because it comes from the 40 problems come out of the pool of about 105 possible questions, and once and even the same question um, has different numbers. In other words, the inputs are different, right? Input data are different. So no two people have the same set of problems, and they are, even if they are same set of problems, as I said, all different input data, and they are all scrambled, right? The problems are not in the same order, and they are all jumbled and scrambled. And so when I did this work, the problem set I got was what I got, and it could be different, completely different from other people's problem set. And even if it's the same problem set, I mean the problem patterns would be the same. You will find but some people, although the problem patterns are the same, I may have got a problem that nobody else. I may have got a particular problem that nobody else got. Okay, so even when this file is visible, it will be hard to. It won't be easy to follow. Let me just because the order, the problems are not in the same order as your problems. But if you did it right, you can figure it out. Oh, this is about future value of annuity. This is about like two different. I mean, there was a problem like someone started started paying into future value certain amount for the first 20 years, and for in the second and then the next 30 years, this amount, that amount, that patterns, the problem patterns, you will find the problem patterns, but it's not exactly in the same order as yours, right? So it takes effort, time and effort to even study that. All right, so let's go to today's topic, which is present value of annuity, right? The present value of annuity is similar concept. Think about it. All the annuities means cash flow in the future, right? Cash flows in the for finance and economics. I mean, especially for finance, cash flow in the past is less of a concern. Why? Because cash flow in the past is already done. There's nothing you can do about it. Cash flow in the past, the the value of the cash flow in the past is already determined. There is nothing cash flow in the past, there's nothing it's already, past cash flows, right? It's not a question mark. It's certain, right? It's done. But the cash flow, future cash flows, right? That's that that makes it look like free cash flow. So I'm not going to use F. All future cash flows right? We need to value this, right? In other words, we want to know the value of this, right? Present value of this, we want to know. Present value of this, right? So think about it. So some people, confuse, uh, the main reason a lot of people are confused about present value of annuity and future value of annuity is that um, they think um, that they fail to grasp that all these future value, all these cash flows are in the future, right? In the in future value of annuities, all these cash flows are still in the future. It's a time, it's a time one, time two, time three, time four, time five. They are futures, and ultimately, what is the uh, sum of all those future values? That's the future value of annuity, and in present value of annuity, yes, the cash flows are also all in the future. And what you want to know is what is it, what's the value of this at time zero? In other words, the present value of all of that, sum of all the present values. So that's the only difference between the um, present value of annuity and future value of annuity. Um, Actually, uh, uh, so as an as a practical example, right? Let's take a look at this. Well, of course, no, the first one is not very practical or very realistic, but second example will be a very practical one. Now, suppose you won a $10 million lottery. Okay, it's not very realistic because winning a lottery is not something that can happen uh, every day. But when you win the lottery, you have two payout options, right? You have two payout options. One is lump sum. Uh, the other one is annuity. If you choose lump sum, you'll take about 60% of the jackpot amount. Why? Because you have to pay taxes, and the tax that you pay is 39%, which is almost 40%, right? The top tax rate you will have, regardless of your real regardless of your actual tax bracket. uh, Most people, regardless of your actual tax bracket, it doesn't matter, you pay 39% at the top tax rate. Why? Because this is not an earned income, right? Your earned income is your labor income. You worked hard to earn it, and your labor income is taxed um, through every tax bracket. But because you have your taxable income has a limit, right? Your taxable income cannot be, most people would uh, fall under, like most people will fall under like 28% bracket. I mean, if you're making, like $150,000, still your top tax rate will be uh, about 28%. Um, so most people would be falling under 28% tax rate, top tax bracket. So, uh, but that's your earned income, right? For the lottery winnings, it's not earned income, it's a windfall gain. It's a windfall gain. And for windfall gain, you didn't work hard for it, right? You didn't earn it. You just won it through a lottery. So for windfall gains, they apply the top tax rate of 39%. So that's why you get about $6 million after tax. Or if you choose annuities, then you'll receive about $20,000 every month. This 20K is my random, random, arbitrary number, not random, arbitrary number I picked. I picked arbitrarily. Okay, so in reality, I don't know what is the monthly so then and you get it for 30 years. You get it for actually. I checked out the lottery website, and it's actually 29 years. If you choose annuities, you get it over 29 years. But again, let's approximate it as 30 years just to make it simple. Then our question is, which one is better? Huh? Which one is better? In other words, do we pick lump sum, or do we pick annuities? Okay, I ask this question to a lot of people, and most of the times the students say, lump sum. And if I ask, why, and they say, I don't know if I'll be around, I don't know if I'll be around, for the next 30 years. And that is a very, that's a very pessimistic answer, right? Isn't that right? I guess you guys are at best about 20 something. And if you're 28, if you're 20 something, unless you lead a very reckless lifestyle, you'll most likely live up to the average life expectancy, right? And what is average life expectancy? Well, currently in the US, average life expectancy would be about 80 something, 81, 82 for male, slightly higher than that for female, probably 84, 85 for female. But that's what average life expectancy means, based on the assumption that you don't lead a reckless lifestyle and you are eating healthy, you exercise, don't smoke, or even if you smoke, not excessively, or you don't drink, alcohol excessively, based on all that, most likely, of course, you could be an outlier, but the chances of being falling into that outlier range, in other words, this is normal distribution curve, and being an outlier means, let's say average life expectancy is 82, let's say, right? That means most people and what if the standard deviation is, let's say, about 2 years? So this would be 80, this would be 84, and this would be 86, this would be 78. And then being an outlier means you fall into this range, and that's only about 2% probability. This is only about 2% probability. Of course, you could fall into this 2%, but the probability of falling, this means this is 96%, right? Probability of falling within this 96% range is higher than, 96 is higher than the way bigger probability than falling into that 2% tail end, right? 2% tail end. So the question is, again, the question is then again, now understanding this, if I ask you a question again, do you prefer lump sum, which is lump sum cash payout, which is 6 million, or do you prefer annuities?
Annuities.
Okay, who said annuities?
Samira.
Who said it? Samira. But you don't know, Samira, you don't know, the only thing you know that the annuities are 20K, and there will be a 360 of them, right? Because it's 30 years, right? Of course, 20K times 360 is 7.2 million, right? But again, one thing you have to understand is that you might think, oh, that's 7.2 million, so that's greater than this, so I'll go for annuities.
No, Professor, that's the future value of that. So
Yeah.
that's
But this is not.
after
No,
30 years.
No. That's not the future value, right? First of all, you know how to find future value. This is not how you find future value. The future value of these annuities, if you want future value, right, it will be like, you'll have to plug it into this formula, payment times 1 plus r raised to n minus 1 over r, right? That's the future value, not this one. This is simply not this one, right? This is simply 20K times 360, and you should remember, you should understand, this 77.2 million doesn't exist at any single point in time. In other words, this 7.2 million doesn't exist 30 years later. It doesn't exist today. It doesn't exist anywhere within those 30 years. It's just a simple aggregation. It's just simple aggregation of all those 20Ks. So it doesn't exist at a single point in time, right? If you want, you can find future value of annuities. But then if you find the future value of annuities, then the problem is you can't directly compare it with this. You can't compare it with this. Why? This is present value. Isn't that right? You are taking this, if you choose lump sum, you are taking this today. So this is present value at time 0. And the future value that you just calculated is the future value, which is not 7.2 million. This is future value at 30 years later, right?
Yes.
Time 360, right? So you can't make direct comparison. But then that's why we are talking about present value of annuities, right? We can find the present value of all of these 20Ks. So if we find, if you find the present value of all these annuities, then the question is, oh, which one is greater? Is it like this or is it like this? And which now then they are, because they are both present value and present value, right? They are present values. So now you can make the decision. Whichever is greater, that's what you pick. Okay? And then how do you find the present value? Well, the formula is, I put it there, but in the slide, in the PowerPoint, but uh, present value of annuities is payment over R minus payment over R times 1 plus R raised to N. Okay? So if we use that formula, right, of course, so we'll, that's present value of annuities. Again, the idea is like, we can't possibly do this, right? We can't possibly do, I mean, this is a scaled down version. It's a simplified version, right? So you have only 5 payments annual, right, at the end of every year. So you can do it like this, but when we have 360 payments, right, we can't possibly do this. So we need reduced form formula. I mean, which, and this reduced form formula comes from the, think about it. It's originally it was like, if you think about it, present value of annuities are, first of all, you are summing up all, first payment, 1 plus R, right? And then the second payment will be 1 plus R raised squared plus, third payment. So basically, we can express it like this, right? Present value of annuities are payment, discounted to present, where n runs from 1 through the terminal time, the maturity, 360 in this case. But this is 360 of them, so there's no way you can do it like in the graphic representation. But that's exactly this. This formula turns into this, and I will show you later, if I have time, I will show you later how this turns into this. Okay. So let's go back to let's go to our Excel file. Now I need you to have this in front of you, right? Do you have it in front of you?
1 second.
Yes.
I'm opening it right now.
Okay, sure, yeah. Well, you should open it right away. As every day we, in every class we use this. So you need to, and after every class, you have this file that you have worked out. So you have to keep it. Next class, you have to open it. And if you have it open, please go to row 17. This is
Okay, I'm ready.
exactly, you're ready? Okay, so go to row 17. This is exactly our example. $20,000. The average market rate is 6%, 30 years. Monthly compounding, right? Monthly. So, well, then, of course, we'll need to have this filled in, periodic rate. What happened? Okay, periodic rate. We know it's going to be 0.5%. And this one, 360 because it's 3 times 12, 360. And using this formula, right? Payment over R minus payment over R times 1 plus R raised to N and close parenthesis. Okay. You might wonder, oh, there's no parenthesis here in the math. No, we don't need, parenthesis in the denominator because the human brain can easily tell that, this is one chunk. Right? So, oh, that's the denominator. But when you put it into Excel, you put it linearly. And when it is put linearly, PEMDAS matters, PEMDAS, right? Because without these parentheses, what Excel is going to do is it's going to divide A17 by E17 first, and then multiply it by this. It's going to be a whole different thing. So you need to put parentheses around the denominator to communicate clearly to the computer that this whole chunk is this is a one chunk and it's the denominator. If you do that, okay, it comes out as 3.335 million. So if this is the case, what is your choice? What is your choice?
The 6 million.
Let's say that again.
The 6 million. We get
Yeah,
at
yeah,
the
you
beginning.
take 6 million. Yeah, you take 6 million. You take the lump sum, right? Because our goal, you shouldn't lose perspective. Why are we doing this? We are doing this because we want to know which one is a better option, right? Lump sum or annuities. Was it Samira? Right?
Yes.
Okay, Samira, you're getting 0.5. Today is April 5th, right? So obviously, now we are able to compare, right? But then also think about it. Present value and future value, both of them, they are all very sensitive. I mean, they are affected greatly by what interest rate is, what the interest rate is. Isn't that right? Especially present value. And of course, in future value, if the greater the interest rate, the greater the future value. But in present value, the greater the interest rate, the smaller, the higher the interest rate, the smaller the present value, right? Because it's discount rate. Interest rate is discount rate, and it is in the denominator. Whatever is making denominator greater, it will make the whole fraction smaller, right? Because of that, if interest rate is higher, then we'll get something like this. Then you go for, but 6% interest rate is not realistic, right? We haven't seen 6% interest rate for very, very long time. For ever since 2008, no interest rate has been ever been near 6%. So what if the interest rate is something like 1%? It will be a different story, totally different story. Isn't that right? And this is more realistic because since 2008, the only interest rate we have seen is somewhere near under 1%, right? Somewhere near, Fed funds rate. They raised, Fed funds rate in the last meeting, and the Fed funds rate is now between 0.25 and 0.5% range. and then even if they raise it 6 times during this year, right? That's 1.5. Uh, so the range at the end of this year, it will be around 1.75 and 2. So let's be more realistic. So if the interest rate is 1%, then all you need to do is just copy and drag it, copy and drag. And then you come to the present value of all those annuities will be 6.218 million. And if this is the case, what's your choice? What do you do? Hmm?
We take the monthly payment 20K.
Yeah, you should. If that's the case, you take annuities, of course, right?
But
And it's
Professor, from the formula also we can say, because payment is divided by R. So if R is the smaller, then we have a bigger number for present value.
yeah. That's the logic. Uh, because if R goes down, right, by the mathematical construct of it, if R goes down, which makes the denominator go down, then of course you'll have bigger, PVA must go up. This is what it is saying. There's this, arrow, right? When R goes down, this goes up, right? Yeah. So that was Samira, right? Okay, you're getting 1 point because you didn't just you provided the logic behind it, right? All right. So let's go to our next question. Our next question, next example. Our next example is. I said this is more, closer to the reality, or more practical. I'm saying this is more practical. Now, let me rephrase. Uh, the wording is rather when I put these things into a PowerPoint, I have to make it I have to condense it because you can't be very wordy in PowerPoint. So so this is condensed. So the language doesn't sound like very natural. But the point is to paraphrase it. It's like this: you want to buy a car, and the price of the car is $30,000, right? Uh, so you may have already $30,000. I mean, you may be a billionaire, and the $30,000 may be just a peanut to you. So you can pay out cash. You can just pay in cash. But um, even if you're a billionaire, you would still consider, financing. So why? I'll explain shortly. So you want to buy this, but let's say whether you have money or not, you will borrow. You're gonna make a down payment, 20% down payment. So 20% of 20% is 6,000. So after making 6,000 down payment, um, the remaining balance of 24K will be financed, meaning you'll borrow money to. And when you go to buy a car, you might think, oh, so I must contact the bank first, and I must get a loan first. No, they all take care of that at the dealership, right? Uh, as you are sitting there, they hook you up with the bank, right? Uh, in other words, they arrange the loan. The dealership arranges a loan uh, with the bank that they are using. Usually, car makers have their own bank for financing, right? GM, Ford, Hyundai, Kia, uh, they all have their own bank. So the financing is automatically provided. Or even if it is, the dealership may use a third party. Um, third-party bank, and it's all arranged there. So the point is, so you borrow, you make so you borrow 24K, and you paid back over 5 years in monthly payment. Now think about it. This is how the borrowing goes. Suppose you borrow $1 million to buy a house, and then so interest rate is something, let's say interest rate is 10%. You borrowed $1 million for 30 years. Now, does the lender wait 30 years for you to come up with the future value of that? In other words, you might when you borrow $1 million annual, the interest rate annual rate is 10%. So 30 years later, so what I owe them is future value calculation. 1 million times 1.1 raised to 30. So that means that future value. I can pay back this 30 years later. No, think about it. Is there any lender that waits 30 years?
No, they just let you make your
No.
monthly payments.
Exactly.
Yeah.
So I mean that was single cash flow model, and single cash flow model is something like this: you buy a stock, right? Using $1 million. I mean, you invest, $1 million in, let's say Tesla, so that you buy stocks and you keep it, and Tesla's average return, average annual return is, let's say, 10%. Then, so that's average. So it may not, each year, it may not be exactly the same, but on average, you can expect. And for 30 years, right, you put that, you don't sell, you just keep it in Tesla. 30 years later, that will be an indicator of how much your stock, your equity position will be worth 30 years later. But when you borrow money, it's not like that, because the lender wants you to make the payment already from the next month in monthly installment, right? So from your perspective, it is borrowing. From lender's perspective, it is lending. And so it's the annuity. And the question is, so there can be two questions. Two questions. Two questions can arise from this. Okay, one, so 24K is the amount you owe. 24K is what you owe. So this is the principal, right? Then your question is, what is my exact monthly payment, right? The second question, the dealership told you this is 500. Then your question will be, then is this the correct payment or not? Is this the correct payment or not? If it is the correct payment, then what can you say? The present value of all of those, the present value of all of these $500 should be equal to 24K, right? If it is not,
Yeah.
if the present value is greater than this 24K, you are being ripped off. You're being overcharged, right? If the present value of that is less than 24K, then you're being
discount.
Yeah, or you are ripping them off, right? You are being, undercharged, right? But of course, this is not likely to happen, right? This is not likely to happen, right? Of course, this is not likely to happen either. I mean, But if ever, by some error, by computer error, right? Whatever. So it can be a twofold. Let's first answer. Okay, go to and think about it. This is exactly that problem, right? Your monthly payment is 500. Your APR 6%, 5 years. So, we need to. We don't need to do it again. Just copy and paste it, and then what say you? Your conclusion is this the correct payment? Is $500 correct payment?
No,
No, no, it's not. Huh? Why? Uh, you have
it's
been
more than principal.
overcharged. Hmm? It's greater than the principal, so you are overcharged, right?
Yeah, by like
You are overcharged.
120 or something. Yeah.
Yeah, you are. So our next question is how do we figure out what is the exact payment? We can we'll talk about that after the break. Okay, I think it is a good time to take a break. But you can tell. Oh well, you have overpaid. 1,000. 1,862. You have right. You have if you will be overpaying 1,862 if 500 is what they say. But if this is the case, and what is the correct, you can calculate the correct payment. You can calculate the correct payment, right? And then even this alone is the proof. So then you got to call your lawyer, right? This is a scandalous lawsuit because a car company. It's the dealership, not the car company. Uh, But anyway, so let's take a 10-minute break and reconvene at 12. All right? All righty. So let me see you there. All right, we're back. We're back. Um, so let's get back to our Excel file. And so um, let's go to row 23. And row 23 is exactly this problem, uh, the car financing problem. And we are trying to nail exactly what the payment is, what the correct payment is. And to do that, let's think about it. We need to solve this equation for payment, right? The equation is uh, basically a present value of annuities is payment over R minus payment over R times 1 plus R raised to N. And you might have noticed that this formula is not in its simplest form, right? It's not in its simplest form. Um, why? Because, uh, uh, but there is a reason why I prefer to use it in this way, because this is the by this formula it shows the effect of this formula uh, gives a stark illustration of the effect of change in R and the effect of change in N. In other words, uh, because the effect works in opposite ways, right? We all know if this goes up, right, R goes up, uh, uh, the present value goes down, right? And vice versa, right? If interest rate goes up, the present value goes down, where also when interest rate goes down, and whereas in case of N, when N goes up, PVA goes up. When N goes down, PVA goes down. So there is a positive correlation between N and present value of annuities, whereas there is an inverse relationship, right? Negative correlation between R and P. And if you express it this way, if you put the formula this way, then these effects are clearly, separated. In other words, which one reduces or increases the present value of annuities. I'm gonna get to that later, if I have. But the point is, this formula, right? We know you can make it. You can make it. You can simplify it further. Why? Because we have a common factor. Common factor is payment over R, right? You have payment over R there, payment over R here. So when there's a common factor, what do? You factor out the common factor. So you think, oh, okay, I'm going to factor out this. And inside the parenthesis, then it's going to be 1 minus 1 over 1 plus R raised to N. Okay? That's why you see different versions of the formula everywhere. In the textbook, actually, the textbook is giving you a formula like this, if ever. Uh, textbook formula is But think about it. It's the same thing. It's the same thing, right? Um, this just doesn't look, to me, this just this just isn't necessary. I mean, it just makes it too complicated. But basically the same formula, right? Uh, so I'm not gonna. Um, Now think about it. Basically, although we can factor out payment over R, right? Uh, we don't need. Actually, what I want to do is just factor out payment. If I factor out payment only, right? What this becomes, you can factor out payment only deliberately. This becomes 1 over R, right? This one is, R time 1 over R times 1 plus R raised to N, right? And then we know we can simplify the thing in the bracket by finding the common denominator. I mean, actually, it's a common multiplier, right? Common denominator in this case is common multiplier. The common multiplier or common denominator here is R times 1 plus R raised to N, right? And so you can consolidate or unify the denominator, and then that means, this term was multiplied by 1 plus R to the N. So whatever you did to the denominator, you have to do the same to the numerator. So you multiply 1 plus R to the N to the numerator, and that's what 1 becomes this, and this one doesn't change because it was already 1 over R times 1 plus R to the N, right? But then think about it. The reason this is, basically the left-hand side is present value of annuities, right? The left-hand side of the equation is still PVA. You have to always, the reason that the math is wonderful is that you don't have to repeat anything. You'll just, left-hand side keeps on going. It's tagging along because it says, PVA is equal to this, which is equal to this, which is equal to this, and you shouldn't lose the perspective, right? When there is this equal sign, everyone should wonder. I mean, some people lose the perspective, but they don't wonder what this is for. Well, that means, it is equal to. Still, it's equal to this. That's what it means, right? So then think about it. Now, the reason I factored out only payment is because of this. This is something I say all the time. When you have, when you have, no matter how complex any equation may look, as long as you can identify z equals x times y structure, right? If you can identify the structure, you can solve any equation. Isn't it right? And by factoring out only payment, we already have brought it to this format. Isn't that right? We already, and solving for x which is the payment, it's not difficult, right? It's total, so how do we do that now? Well, we know then payment is the,
You
if you
divide
solve
by
it for P,
PVA.
divide by PVA. No, you divide PVA by the thing in the bracket, right? Isn't that right?
Yeah. Yep.
Yeah. And we all know that dividing by something is the same thing as multiplying by the reciprocal, right? Dividing by something is the same thing as multiplying by the reciprocal. So I will multiply that PVA by the reciprocal of the thing in the bracket. So if I rearrange this, right, then we come to present value of annuities times the reciprocal is R times 1 plus R to the raised. Why is it moving like? Raised to n, and then 1 plus. 1 plus R raised to n minus 1. Okay, everyone is okay with this formula. I mean, the steps of derivation, right? Everyone is okay with the process.
Yeah.
Okay, good. So then this is we got we nailed the formula for the payment. So if we apply that formula now, and I put it already here, so you get right. So we'll do exactly that, right? Okay, equal sign. So PVA times, okay, and R times 1 plus R. Oh, no, what did I do? R is this, right? Raised to n, or open parenthesis, open another one, 1 plus R raised to n minus 1, close parenthesis. Okay? If you hit enter, of course, nothing will show there because, there's nothing here, but we already know. It's just, matter of, then we get this already, which is, I'll put it into dollars. I'll put $sign unnecessarily too. It's going to come to 463.99, right? 463.99. So that's exactly what it confirms, right? From this, we already concluded that we are being overcharged, right? And it's obvious we're being overcharged because this is greater than 24K. And if the payment is correct, all those, if correct payment, the present value of all those correct payments must be exactly equal to present value of annuities, PVA, 24K. So here, the payment is, this is the proof that they have been overcharging us by about $40 every month. Isn't that right? By about $40 every month. Okay. So everyone got the same result?
Yes.
Everyone? Okay, good. All right. Samira, did you get the same result? All right. How many people are here? Okay. Samira's not here. All right. Um, so 463, right? Now, we can also apply this to, let's say, if to that, lottery example. Suppose you won, the jackpot, and um, so if you take the lump sum, right, it will be 6 million. I mean, if we turn it into annuities, the 6 million into annuities, what should be the payment? Under 6%, under 1%, right? Copy and paste here. Oh, because these were not filled, but we know what to do. Okay, so under 6% assumption, right? This $6 million, right? The monthly payment should be like almost $36,000. Wow, if they pay us this, then that's wonderful. Exactly this, that would be wonderful. But if they on the 1% assumption, right? The one month, monthly payment would be almost, slightly less than, $700 less than 20K. So if they pay us 20K monthly, it's still a good deal, right? It's a good deal, right? Now, so this brings us, once we are able to calculate monthly payment, this brings us to the question of, the amortization. This brings us to the question of amortization. So what is an amortization? Amortization is literally to amortize. The verb is to amortize. And what is, it means paying down the debt, right? But why pay down? Pay down means, you're gradually reducing the principal balance, right? You're gradually reducing the principal balance. So you bring the debt to its own demise, right? The word amortization, right? Think about it. The radical of the word is this. And what is that? That means death, like mortician, mortal, right? Mortal, mortify, morgue, anything, the Latin root, that means, death, right? So it sounds very, ominous, right? But what it means is you're bringing death to its death, its own demise, right? Bringing,
Yeah, so you're like killing the debt.
yeah, gradually, right? Not just killing it off right away, but gradually. Um, so if you and then that is equal. That's pretty much the same thing as this is what it means: pay down the debt. because pay down, if you pay down the debt, that means, the balance gradually, right? Gradually, declines like this, right? So this was the original principle, original level of, original principle. And then over time,
Because the interest rate gets less and less with the lower principal. I
no,
mean,
interest rate,
it doesn't
interest
change,
rate,
but it doesn't.
the interest, dollar amount of interest will go down,
Yeah, exactly. Yeah, yeah.
right? Because obviously, as you make the payment, the principal goes down. And as the principal goes down, the interest paid will go down, right? Dollar amount of interest will go down. Now, so you're right. And who said that? It was Lewis, right?
Lewis, yeah.
Okay. That was Lewis who said that, right?
Yeah, yeah.
Okay, Lewis. Okay. Yeah, you got uh, you're getting 0.5. Yeah. And think about it. This pattern, right? It's gradual decline, and this pattern is called decay, right? It's decaying, right? Gradually, and when things decay, right? When any organism decays, right? That means eventually the end of it is death, isn't it right? Hmm? Anything decays, end of it is, its demise. I mean, not only the organisms, but even inorganic matters. Um, uh, on the metal, rust, right? That is what makes it decay, right? The metal, right? Lime, calcium, lime, rust. Uh, Eventually, uh, that's the evidence of decay on those inorganic matters as well. Anything decays, eventually comes to death. So here's basically here's an example. You see, this is like a 30-year mortgage payment. Someone got a loan, mortgage loan, and it looks like this is not the more. What's happening? So you might think, oh, that's the amount of mortgage. No, no. It looks like this is the total of all 360 payments, but so it looks like the mortgage was probably about $200,000 or something like that. The principal, right? Mortgage principal was probably about 200,000. Now, and you're making monthly payments, and at the beginning, right, 2010, the level of so that was probably 200,000 or 240,000 or whatever. Over time, right, it gradually declines. Finally, 30 years later, zero, and the monthly payments are $699, almost $700. And you might wonder, and so the bar is so it looks like annual, right? Annual payments. The bar is even, of course, because all your monthly payments must be monthly payments is constant, always this amount. And then this yellow bar is the principal. The interest paid, right, every month. And then the green bar is the principal paid every month. So in other words, you might think, if you're making $700 monthly payments on your mortgage, you might think, 500, 500 must be the principal and 200 must be the interest every month. No, it's not like that. The proportion, the composition will change every month. The composition will change every month. So interest declines in decaying pattern over time, and the principal increases, right? Principal payment increases um, exponentially over time. Now, from the this is called decaying pattern, but this is called exploding pattern. And if you look at it from interest perspective, interest declines in a decaying pattern, whereas a principal increases in an exploding or exponential pattern. Okay, now I'll get to that. But another thing you might wonder is, if this is like 24K at 240,000, if this level is 240,000, and then the same level, same height, that's $700. How can it make sense? Uh, uh, right? How can it make sense? Actually, you have to understand that they use two different axes. Okay, two different axes. What I'm talking about is now. This is for principal balance. This is this axis. The left vertical axis is principal. Let me call it PB, principal balance, and the right axis, the right vertical axis, there is a right vertical axis. This is payment. And the increment, each increment here is like 10K. Okay, each increment here is 10K, and each increment here is like $100. Okay, does that make sense? Okay, let's say $50.
Yes.
Yeah, you're back, huh?
Yes, Professor, I couldn't hear you for a while because I tried to log in, log out 100 times, but I don't know what happened.
Okay, all right. So think about it. Then about 12 of them, or seven of, if it is $50, right? 20 will make 500. Let's make it 100. Just to make it easier. If each increment is $100, right? Just about 7 of them will be like $700. In other words, if you use, let's say that's like 700. If you use different scale on each axis, right? We can represent both in a more visible way, right? Otherwise, if we use the same axis, the monthly payments will be only somewhere here. Monthly payments will, somewhere here. So there's no way you can effectively show the splitting of, interest and principal paid, right? So,
I have a question.
Yeah.
Can you go back to the last chart? So
You mean this?
yeah. So let's say
Mhm.
you turn the 100 into like 300. Would you essentially just pay it off faster? You would like, and then
You mean, of course, of
yeah,
course. If you make $300 monthly payments every, no, the 100 is no, look, it's just 100 is just the uh, notch, each notch, right?
yeah,
To show the increment on the vertical. Um, in the original example, a monthly payment is 700. Of course, if you increase the monthly payment to 800, of course it has to be even. I mean, it shouldn't be sporadic. Even if you make sporadic larger payment, it will still help because it you know it lowers the principal balance. Uh, but if you want to increase it, you better increase it. On uh, to make it annuities, it has to be a regular amount at regular interval. So if you raise it to 700, to 800, right? Then it has to be 800 every month, right? From there on. Of course, you pay off much, faster, right? All righty.
But
That's
yeah,
Professor,
yeah,
the first years of our payment, it looks like mostly of they collect their interest,
yeah, yeah.
and
That's the
then
idea. Early on, out of this $700 monthly payment, uh, a lot of it a lot of it is, most of it is interest. And interest declines, right, in a decaying pattern over time. And the rest of it is payment, the principal increases uh, exponentially over time. And I already explained, it's because the principal balance is going down. As the principal balance is going down, obviously interest will have to be smaller, right? So we're gonna I think we don't have time for the we don't have time for the example. So we're gonna do the example next time. But as we do the example, you will see why. You will see, right? You will see why. And uh, one one more question is, one last question is, some people might say, right, uh, when we do this, payment um, all along. I said, if the payment is correct, right? If the payment is correct, I said, uh, then uh, this should be exactly 24K, right? In that car financing example, if the payment is correct, it should be exactly 24K. Then some people ask me in the past. Some people have asked me, Professor, shouldn't this be shouldn't the pay, present value of annuities be greater than 24K because there is interest? uh no. Why? What you're saying is, what that person is saying is actually, uh, sum of all the payments sum of all the payments must be greater than 24K, right? Sum of all, so there are 60 payments, right? Sum of all those 60 payments should be greater than 24K because each payment includes both principal and interest, right? But the present value of all these payments, this is the present value of uh, basically, oops, what did I do? This is the present value of all those payments, right? It's the present value of all those payments. So the present value of those payments must be exactly equal to 24K, right? Makes sense? In other words, all those payments
Yeah.
already include interest. You don't have to worry about interest, right? Uh, because eventually sum of all those payments are greater than the principal, right? Interest have been paid, right? So basically, present value of all of them must be equal to 24K. It's just like, think about it. Um, um, in a single cash flow model, if we do this, this is future value. But if you discount future value, then it should be exactly the principal, the same idea, right? It should be exact. So if this is the all the payments, right? Present value of all those payments, sum of all the payments, that's like future value. If you discount it, right? This is the present value of all of that, right? This is the present value. Present value must be exactly equal to 24K, right? Of course, future value is greater than uh, future value is greater than um, principal, right? Of course, that's the of course future value is greater than principal, right? So you're making this type of comparison, right? And this is like alrighty. So I think that's all the time we have. Any questions so far? Any questions? There any questions? Hmm? Okay, no questions. All right, so if there are no questions, um, we're gonna do this amortization schedule next in the next class, which will be Thursday, right? Uh, and have a great afternoon, everyone. And I will see you guys on Thursday. Okay? All righty. So
Professor, can I talk to you after the class
yeah, sure, yeah.
here?
All right. All right. So class is dismissed. If you need to speak to me, just stick around. All right. Stop recording.